Hey, algebra class. All right, one of the things we definitely would have gotten into if we were still in school, some imaginary numbers. So the I guys, we are back with these. This is a short introduction to imaginary numbers. You're going to like these guys. Yeah, maybe. All right, let's do some of these. So what happens on these imaginary numbers is you have, say, a square root of like 49. Like, well, we know square root of 49. It's going to be 7. But what gets crazy is when there's a negative sign in there, like negative 49. You can't take the square root of a negative number. Aha! You get into these imaginary values. So, math way to write this, you grab this negative sign, and it is represented on the outside as an I value. So this negative sign, you have to rep it with an I value on the outside the square root. So, negative inside, I on the outside. We know square root of 49. Square root of 49 is 7. So this, my friends, square root of negative 49, 7i. So this is the math process, if you were showing your steps, how you would get there. Of course, you guys aren't going to do that. You're like, Mr. Porter, I'm not showing any steps. So if I had something like square root of negative 81, this negative means there's an I value. Square root of 81, we know that's 9. So this would be 9i. That's what you guys would write. Okay. One thing that's an important fact that you would have to have memorized for the rest of your life if you'd been in school is right here. We know I squared must equal negative 1. So like forever, you should have had to know this. I squared is negative 1. This shows up in lots of math problems. I squared, negative 1. I squared, negative 1. I squared, negative 1. All right, let's do a math problem that shows up where you would have to do this. Let's say you had, how about negative 2 and negative 32. Now, there's a process when you solve a problem like this with the negatives inside. The first thing you have to take care of is the negative sign and the negative sign. You have to write those as i's. So this becomes I square roots of 2, I square roots of 32. So you do that first. And now we have i's on the outsides, 2 and 32 on the insides. So we take our values for the outsides, the I and the I, we put those together. We take the 2 and the 32. They're on the inside of the square root. They multiply together. Now watch this. I times I, oh, that's I squared. 2 times 32, that's 64. You're like, okay, I squared, we just learned this. I squared is equal to negative 1. I squared, negative 1. I squared, negative 1. So this becomes negative 1. I squared is negative 1. And then we know square root is 64. It's 8. So negative 1 times 8, negative 8. Ha ha ha. So this would have been kind of a fun math problem to build in all kinds of other fan math problems. You would have dug it. Let's do another one of these. I squared, negative 1. I squared, negative 1. What do I got here? Number 5. So we got 54 times a negative 6. Okay, same process involved. Same thing we're doing here for number 5. We've got negative and negative. You have to do this first. You must take care of the I value. You must take care of the I value. So before you do anything else, get those I's. Now we can go guys on the outside, guys on the insides. I times I. Inside values, 54 times the 6. All right, here we go. I times I, that is I squared. 54 times 6, 324. Now we're in business. We've got I squared. I squared for the rest of your life is equal to negative 1. That's negative 1. Anybody remember square root of 324? Somewhere between 17 and 19? Yes, 18 it is. So negative 1 times 18, that is negative 18. All right, so that's a second type of problem. I have a third type of problem for you today. So on this introduction to imaginary numbers, we like this one too. Okay, so here is a list of I values, first power, second power, third power, fourth power. So this is a list that you need to have down. I to the first, that's just I. And we just figured out I squared is -1. I to the third is the one that people never remember. Like they get like, I can't remember I to the third. It's -I. And then the golden child, the most important one, I to the fourth, most important one, I to the fourth is +1. Now what's weird about your I values and this pattern right here is this just repeats. So I, -1, -I, 1 keeps repeating as you go on up the ladder. So what I'm telling you is you could have I to the fifth, I to the sixth, I to the seventh, I to the eighth. This just keeps repeating. So I to the eighth, +1. I to the sixth, -1. You could keep going. You could do I to the ninth, 10th, 11th, 12th. This pattern is always intact. Always. All right, let's go back to the way we had it. You could just keep on building forever. It's all in this row of 4. So I to the first, I to the second, I to the third, I to the fourth. But the big money important guy is right here, I to the fourth, +1. I to the fourth, +1. So when we solve these next problems, you have to remember all multiples of 4 turn out to be +1. So if you have I to the fourth, that's 1. I to the eighth, multiple of 4, that's 1. I to the 20th, that's a multiple of 4, it's 1. What's another multiple of 4? 400. I to the 400th, 1. Any multiple of 4 always turns out to be 1 every time. So knowing that, this is a pretty slick little move to help you solve these next problems. All right, let's put it up there. So for number 7, there's a cool Price is Right maneuver. I know I've shown you guys all kinds of moves and tricks throughout the whole semester, but this is my Price is Right move. It's pretty good. So let's say you have I to the 23rd, and you don't feel like just writing I 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 30. You don't want to count all the way to 23. So there's a Price is Right move that'll do this a lot quicker. So you take your I value, and you're going to split this into 2 parts. Your first one is your multiple of 4, but it's the closest multiple of 4 without going over. So just like Price is Right, whoever's closest, but you can't go over. So closest multiple of 4 to 23. Like is 16 the closest multiple? No. 20 is the closest. 24 goes over. So your closest multiple of 4 to 23 without going over would be I to the 20th. That's the closest without going over. Now if there's 23 of them, you subtract 20, you have 3 left for the second I. So I to the 20th and I to the 3rd is what I to the 23rd becomes. So you take 23 and you split it into 2 parts. But watch this move. I to the 20th is a multiple of 4. What does every multiple of 4 turn out to be? +1. And then we just had this list, I to the 3rd, it's equal to -I. So you look back at your list, maybe I can put it right here, I to the 1st, I to the 2nd, I to the 3rd, I to the 4th. So this is I, -1, -I1. Can you guys see that? Just barely. Okay. So yes, I to the 3rd, -I, 1 times -I, that's -I. So remember, split it into 2 parts, closest multiple of 4 without going over. Multiples of 4 always turn out to be 1, and then you can get your answer. Let's do another one. Let's see here. How about number 8? So we just did 23. What if we did like 82? Now there's no way you want to count all the way to 82. So you're like, I'm using that Price is Right move. I'm going to split this into 2 I's. And I need the closest multiple of 4 that I can get to 82 without going over. So all the way up, I believe 80 would be your closest multiple of 4. But you got to remember what's left. If I had 82, 80 of it's here, 2 more is there. So you got 80 and you got 2. This is a multiple of 4, and any multiple of 4 turns out to give you 1. I squared, we look at our list, I squared, -1. And then 1 times -1, that's my answer, -1. All right, one more Price is Right move, then we're going to do some math problems. All right, let's count it huge here for this last one. How about I to 201? You're like, whoa, that is huge. Kind of like Mr. Porter. All right, let's split it into two parts. So you need the closest multiple of 4 to 201 that you can get without going over. Well, let's bump it up there. It goes all the way to 200, which means you have a first left over. 200 plus 1, 201. That's how you split it. Okay, every multiple of 4 turns out to be positive 1. That's a multiple of 4. Turns out to be positive 1. I to the first, that's just I. And guess what? 1 times I, that's just I, and that's my answer. All right, so this was your introduction to fun problems with imaginary numbers. So here's the deal. I'm going to put some math problems on this little tiny board right now. And this is your assignment. You're going to write these problems down. You're going to copy them on your own paper. You're going to make it look perfect. You're going to write the question. You're going to box your answer. You're going to take a picture of it that looks awesome, and then you're just going to email me the picture. I think it's going to be perfect. So here we go. Your homework assignment. And I've got 8 questions. All right, here's the first 3. I might be able to, yeah, I can get number 4 down here. Okay, so there's your first 4, and there's a total of 8 of these. So here's 1, 2, 3, 4. And then we'll get 5, 6, 7, 8 up on the board right now. All right, 1, 2, 3, 4. So here's 5. And then our powers here. So we'll do I, 42, number 7 will be I, to the 17th, and number 8, I, to the 83rd. So you only have 8 homework problems. Put them down on your own paper, write the question, make it look really neat, box your answer, take a picture of it, email me the picture, and we will call it good. All right, guys, there you have it.